This is David, WA901Y. I'm going to show the deep nulls that are broadside to an electrically small loop antenna. We use a KiwiSDR. KiwiSDR is this silver box here. It's got a LAN connection, a power connection, a GPS receiver, and a receiver from 1 kilohertz to 30 megahertz. This is connected 25 feet of video cable to this loop. This loop has 49 turns of number 22 magnet wire in it. The loop will be orientated so that it's broadside to the direction of what the rotor shows. Let's go ahead and close this out and look at the waterfall. Here's a signal that just stopped. That's from Russia, RDL. Anyway, let's go over all the far away. At just below 20 kilohertz is NWC from Western Australia. Russia here just above 21 kilohertz, stopped. NPM is the station in Hawaii. It's probably the second strongest station on this waterfall. A weak station from JJI in Japan. Extremely weak station from France, HWU, and we'll see that changing slightly as the rotors change. We got a NAA in Massachusetts, and our strongest station is in the state of Washington, NLK at 1.2 megawatts of transmitting power, and it's at 7 degrees direction from us. To see the change in the signal strength, I'm going to bring up a S meter. It's one of the extensions here, S meter. And we can see it's a minus 88 dBm, which we can also see down here in the corner. These vertical lines are 1 second markers. We're going to change that to 10 seconds. We're going to expand the scale. We're going to drop this down to a minus 70. And we're going to go up to minus 100. We're going to slow down the speed so we can see more of the chart time on there. We'll clear it, and now we got things going. Let's get some pictures. Let's bring up a live picture of the rotor. There's a live picture right now outside. You can see the little movement in the trees in the background. Eventually you'll see the rotor rotating the antenna. The rotor control is in here in the ham shack. I'll bring that up. It has 2 programmed memories right now that I'm using. A is for 000. This rotor only shows the first 2 digits, doesn't show the unit digits, so you multiply this by 10. We also have 2 indicators for counterclockwise and clockwise directions. You'll see those lit as we go one way and the opposite way. So everything's all set up. What we're going to see is a deep null when the broadside of the rotor is facing 7 degrees or 187. So let's go ahead and start the rotor, doing a full sweep from 0 to 360 degrees. We can see the rotor changing now in the picture on the far right, and we see the deep null. There's that deep null there, signal strength, and it's going to max out when we get 90 degrees from that, or 97 degrees. 97 would have been at the top. Well, 180 from 7 is 187, so at 187 we're going to see another deep null. We're coming up. There it was. You'll notice that for some reason the design of this homemade loop is not perfectly symmetrical. This has a deeper null in one side than the other. Anyway, 277 is where we max out again, and we're going to start heading down to 360, which is shy of 7 degrees, which means we don't reach that. We bottom out, so let's now go ahead and change the rotor and go in the opposite direction back to 0. We go ahead and hit the programming memory, and now we're starting the counterclockwise, and it's going rotating as as we see over there. We see that basically the strengths fell here. Japan disappeared. Australia's disappearing. Hey, France got stronger. Here we go. And this is getting weaker here in Hawaii. Of course, that's weaker in Massachusetts. We're hitting a null. We've passed through the null here, as we can see that. So, as we can see, various stations at different bearings will have different effects as far as signal strength on the waterfall. 0 here. Australia just faded into the noise. So this gives you an idea that a small electrically loop is going to have the strong ends right off in the planes, off the ends of the loop, but broadside is where we have these very deep nulls. And this homemade loop, for some reason, has a difference in almost 7 dB of in the null on one side versus the other side. This is David, WA9ONY 73 and QRT.